Dear students, today we'll discuss about multiple cuts or distillates from the TVP graph that is obtained from the atmospheric distillation column. This is a very important topic and see it carefully. Now, as we know that atmospheric distillation column is a simple distillation column, but the difference is there are intermediate products apart from the top and bottom. So in this diagram, a feed is basically charged into the atmospheric distillation column, and we can get the first product, that is called as the cut 1, as intermediate, then the next product, that is a cut 2, then cut 3, and the top product, that is a cut 4. Then there is a one bottom product, that is the residue. So sometimes in intermediates there are more than 3 cuts, maybe 4 and 5 cuts are there. So top products, bottom products, and intermediate products. So these are the 3 classification of products from the atmospheric distillation column. Now the second important terms that we are going to use in the atmospheric distillation column is the concept of adjacent product. Adjacent products, as the name suggests, it is the 2 consecutive products that are come together, that's simply called the adjacent product. For example, cut 1 and cut 2, these 2 products are considered as the adjacent product because after cut 1 we can recover the cut 2, and cut 2 and cut 3 are the adjacent product. Similarly, cut 3 and cut 4 are the adjacent products. So these are the adjacent products. We cannot say cut 1 and cut 3 are the adjacent. No, these 2 are not the adjacent product. Only cut 1, cut 2, and cut 2, cut 3, cut 3 and cut 4, these are the adjacent products. The second important terminology, that is the concept of distillates. All these intermediate product and top product are considered as a distillate, that is a desired product from the atmospheric distillation column. So sometimes these cuts are also designated as distillate. For example, cut 1 can be a D1, cut 2 can be a D2, cut 3 can be a D3, and cut 4 can be a D4, means distillate 1, distillate 2, distillate 3 and distillate 4, and so on. So sometimes you will find that the nomenclature is not given as a cut wise, but it is given in the form of distillate wise, D1 and D2. The other next important point is that we have taken this is cut 1. So after the feed, the first product is taken as the first product, cut 1, distillate 1. Then the next one is taken as a cut 2, distillate 2, product 2, and so on. So that's why we have taken the cut 1 at the first product from the crude oil, from the feed, that is very near to the feedstock, and the last one, that is the top one products. So this is the one way to give the nomenclature of the different products of the atmospheric distillation column. Now let us come to the next slide, where we have to show you all these cuts in the graphical representation, because all our calculations are based on the graphical calculations. So let us look about the presence of these cuts in the graph. So this is a TVP graph, TVP curve. As we know that one of the very important, x-axis is a volume percent, y-axis is a temperature, and these are the cuts: cut 1, cut 2, cut 3 and cut 4. We have all these 4 cuts, and obviously the remaining is the bottom. So we have to first divide all these cuts, means all these distillates, from the bottom. So for example, this is the differentiation between the bottoms and all these distillates, and then they take the random values of all these cuts. So we have taken first all these different cuts. For the cut 1, their range is given from about 44 to about 59, and similarly cut 2, cut 3 and cut 4. So all these are given here as in the atmospheric distillation column, and then the remaining is the residue, that is the bottom product. So basically in these diagram, that is very important, the location of all these cuts, where it is. Now we'll look about the significance, the temperature corresponding to all these cuts, what are the significance. So for that thing, if you have understood about all these, the concept of cut 1, cut 2, or distillates 1, distillate 2, and so on. So the next, that is the terminology, or the next important thing is about the temperature relations and their lighter cuts and heavier cuts concepts. So cuts that are recovered first are called the lighter cuts, then those are recovered later. So don't be confused about it. In other format, it can be found by the TBP graph. Cuts having the low temperature are the lighter than the cuts having the higher temperature. So if you want to see from the TBP graph, cut 4 have the low temperature, because you see their maximum possible temperature is this one, 150. Cut 3 have higher temperature if you want to see their maximum possible, because this is the initial range of cut 3 and this is the final range of cut 3. So if you look about the final range, the value is about 250, round about 250, less than, slightly less than. Then cut 2, see their temperature is more. Cut 1 have the highest temperature in all these 4 different cuts. So low temperature have the lighter one. Obviously low temperature means they are boiling at a very low temperature, that's why we call it a lighter products. And those are boiling at high temperature, we call it the heavier one. So in all these cuts, we can say cut 4 is the lightest, followed by cut 3, cut 2, and cut 1. Cut 1 is the heaviest distillate that we can obtain. After that, residue is there, so we are not going for the residue because our main concentration about the distillates. So as far as they are lighter and heavier are concerned, so be careful about, don't be confused about cut 1 means lighter. No, this is not one. You have to look about their curves, TBP curves, where are their location in the TBP curve. So in this case, cut 4 have the lighter one. Even we can compare two cuts, for example cut 1 and cut 2. So in cut 1 and cut 2 is a lighter and cut 1 is the heavier one. So these are the important concepts in the TBP graph for the multiple cuts, which one is a lighter one, which one is heavier one. So you have to be very much careful about that one. Their ranges are given here, so then we can calculate so many other things. So this is all about the multiple cuts. Thank you very much.